In this video, I'm going to do an example of graphing a vector field. I'm going to do the rotary motion example. It's a very common one, and this is our overview slide, so I will give you a quick overview of what a vector field is and how we approach graphing it, and then I'll go through our particular example. And my main motivation for doing this, for separating out this example from any of my other videos, is for my Math for Physics playlist, because in that video where we talked about graphing vector fields, we had a very complicated vector field. And what it turned out is that vector field was the potential or the gradient of a potential field. And then we looked at the level surfaces of the potential field, and we did all kinds of complicated things. But one, not every vector field is a potential field, and two, many vector fields are much easier to graph. While I had discussed the general ideas of how to represent or how to graph a vector field, even a simpler one, I hadn't done an example. So I really wanted to produce a simple example of graphing a vector field for you. We are going to start by quickly defining what a vector field is and how we represent it. The definition of a vector field, it's a map, F, capital F, that goes from some space, Rn to Rn, and it assigns to each point in X in its domain a vector. So in other words, here's an example of a vector field, which I denote with a capital F. Vector fields I usually like to denote with a capital letter, and it assigns to this point, the point 1, 2. So here's the point 1, 2 in my R2 space, and it's going to assign this vector 4, 3. So here I went over 4 in the X direction, 3 in the Y direction. And the way I want to represent this graphically is I'll attach this vector 4, 3 to the point 1, 2. So in other words, I'm going to move this vector up over here to the point 1, 2. So the thing is, we often draw vectors starting at the origin because that will give us the correct direction and magnitude. When we have 4, 3, we start at the origin, so generally we're talking about 4 units to the right, 3 units to the left. But vectors don't have to stay at the origin. Vectors are really just about preserving direction and magnitude. So here you can see I'm still 4 units to the right and 3 units to the 3 units up. So this is the same vector. I've just moved it from the origin to the point 1, 2. So this is how I would represent this assignment. F at 1, 2 produces the vector 4, 3. Let me do another example for you. Often F is a function. It takes an xy coordinate and it produces another xy coordinate. So for example, f of xy might equal to x squared y for the first coordinate and 3x for the second coordinate. So if I plug in 1, 2 for x and y, I'll get f of 1, 2 is equal to 1 squared times 2, which is 2, and then 3 times our x, which is 1. 3 times 1 is 3. So here is my point 1, 2 over 1, 2 over here. And then I need to draw my vector 2, 3. So here I have vector 2, 3. It goes over 2, up 3. And what I want to do is move this vector, not the 5, over here to my point 1, 2. So this is how I will represent the fact that f at 1, 2, at this point, I have this vector here, which is 2, 3. Also, just to note, the vector field, the capital F, it's different from a scalar function. A scalar function produces a single number, a single real number or complex number. So an example of a scalar function is f of xy, which might be x squared plus y plus 3x. When you plug in 1, 2, you get a single number. So here I'm saying f of 1, 2 is equal to the number 5. And I would just designate it like that. But again, I only give this to you just so that you know there are scalar functions and there are vector functions. Scalar functions take inputs, x, y, z, whatever, however many inputs, and it produces a single number. A vector function takes however many inputs and produces a vector that has magnitude and direction, not just a single point. Now I'm going to give you a more complicated but very common example of rotary motion. We have a vector field which is designated with a capital V. Again, I like to designate my vector fields with capital letters, scalar fields with lowercase, but this is a vector field. and it takes a point in the xy, so two-dimensional coordinate space, and it's equal to minus yx. And what you get is this vector field here. But I'm going to show you now how this drawing gets produced. I'm going to start by plotting some simple numbers. Actually, I really should have started with 0, 0, but I didn't. But 0, 0 doesn't, it just gives you the origin, right? 0, 0 into this function. X equals 0, y equals 0 gives you 0, 0. I'm going to plug in 1, 0, negative 1, 0, 0, 1, 0, negative 1, just some simple numbers to get started. And what I get is for 1, 0, I get the negative value of y, which is just 0, and then x, so 0, 1. For negative 1, 0, I get the negative value of y, which is just 0, and then x, which is negative 1. For 0, negative 1, I take the negative value of y, so I'll get negative 1 and then 0. And then for 0, negative 1, I get the positive 1, because of the positive y, and then the x equals 0. And I also did 1, 1, so let's just throw that in. 1, 1 will give me negative 1, 1. So let's start with 1, 0. So that's this point right over here. And what I have is the vector 0, 1. So 0 in the x direction, 1 in the y direction. So it looks like this. But now I need to move that vector over to my point, to my point 1, 0. So let's move that vector over here. So that's what I need to point at it, not move it. So at the point 1, 0, I have my vector 0, 1. Next, I'm going to go to the point negative 1, 0. So x is equal to negative 1, y is equal to 0. And what I have at this point is the vector 0, negative 1. So 0 in the x direction, negative 1 in the y direction. And again, what I need to do is I need to move this vector over to my point negative 1, 0 has the vector 0, negative 1. Now we go to the point 0, 1. That's this point here. And I'm going to do this a little bit faster. What I need at this point here, I'll just dot it for now, so we can kind of hold that thought. And what I need at this point now is I need the vector that is in the negative x direction by 1 unit at and 0 in the y direction. So it's going to go in the negative 1 direction in the x direction, 0 in the y. I could have drawn it here, right? This would be negative 1, 0. So I could have drawn the arrow and moved it up, but I just already saw here that essentially I just want to have a vector that moves in the negative 1 in the x direction. At the point 0, negative 1, so x equals 0, y equals negative 1, that's this point here. What do I have? I have the vector, and this time I'll just draw it as regular. I have the point that's positive 1 in the x direction, 0 in the y. So that's this vector here, this vector here, which then I want to move to the right position. Not the dot, but the vector over here. So that's my first 4 points, and I need one more point. So at the point 1, 1, so let me get that point 2 as well. The point 1, 1, which is right over here. Maybe I'll make it in blue so you can see it better over here. And I need the vector negative 1, x. So negative 1 in the x direction and 1 in the y direction. So that's this vector over here. Maybe I should make it in blue so you can see. That's this blue vector here, which then I will move to my point 1, 1. Here we go. So that's kind of interesting, but you know what? I want to start connecting my paths. So my next starting point, I'm going to take the end of my last vector, and that point is x equals 0, y equals 2. So for x, y, I'm going to do x equals 0, y equals 2. Then my v of xy, which is equal to negative y x, is going to be equal to negative y is negative 2, 0. So that means negative 2 in the x direction, 0 in the y direction. That's this vector here, which I need to move up to my point 0, negative 2. Now I'm going to take this point as my next starting point, which is the point negative 2, positive 2. So I'll have negative 2 in the x direction, positive 2 in the y, and what that will give me is negative 2, negative 2, right? The y becomes negative, the x stays the same. So negative 2, 2, that's the point negative 2, negative 2 in the y direction. So this is my vector representing negative 2, 2, but I need to move it up to my point over here. So you can see what I'm doing is this one is the start of this arc here. But you know what? We can do one more point. So we're at negative 1, 2, 3, 4. X equals negative 4. Y is equal to 0. So our next point is going to be 0, 4. I'm sorry, I think that should be 0, negative 4. So again, you can draw the point, x equals 0, y is negative 4. So you have this, or you can think of this as from this point, you have something going down in the y direction 4 units. Okay. So again, I've drawn exactly this arc. Let me start the curve and then from this point. So this is at the point negative 1, positive 1, right? X is negative 1, y is positive. So that's going to give me negative 1, negative 1. So starting at this point, I'm going to have the vector negative 1, negative 1, which looks like this, but I need to move it. So I'm going to move this up over here. And now for I'm going to start at this point, which is x equals negative 2, y equals 0, negative 2, 0. So I'm going to get 0, negative 2. So again, I can think of that as being here, and this tells me I want to move in the y direction negative 2 units. Now this point becomes my new point, and it's negative 2 in the x direction, negative 2 in the y direction. So I have negative 2, negative 2. So I get a positive 2, negative 2. So that means from this point, I want to move positive 2 in the x direction, negative 2 in the y direction. Actually, that doesn't look right. I'm sorry, positive 2, negative 2. So in the x direction, I'm going to go positive. I was going negative before. And in the y direction, negative. So I want something at this angle. So I think of moving this arrow. Actually, I'll just draw it. So I'm going to have this arrow here, my positive 2, negative 2, and I will need to move it over to my point negative 2, negative 2. So you can see this arc is, where does this, oh, this arc is starting this curve over here. And I'll let you do more points, but you can see how we're starting this rotary motion here. And actually, it might be worth remembering that v sub xy is equal to negative xy, depending on what type of class you're in. But this is how you can graph a vector field. A quick review of what we did. We said a vector field is a function or a map that goes from some space. In our examples, we did R2 to R2. It assigns to each point in this space, in the R2 space, a vector. And so our first example was f of 1, 2. So this is a point over here, and we assigned the vector 4, 3. So first we drew the vector 4, 3, then we moved it up to the point. That's how we represent a vector field. We looked at how to draw a more complicated vector field, which was this rotary motion given by v of xy equals negative yx, and we went point by point. And one of the things that you can do is just plot a few simple points, but eventually you want to do sort of trace some of the curves. So you start at some point, and then at the ending point, that'll be the next point you plug in, so you get to where you're going to your next point, and you keep iterating until you have a little path. So that's it for this short video. Thank you for watching.